We're going to cover quiz 4, 5, 6, 7. That's chapter 4, 5, and 6. Okay. And let me see. I should be able to use the pen here. Until it's too loud. Okay, so the first one, oops. Oh. So the first question, following table shows the frequency distribution, the credit card for random sample of homeowners who they just recently refinanced their mortgage at Delaware Bank. So the credit score 700 to 727, that's 7 people, and then 14, 25, 16, 8. So probability that if we select homeowner randomly, their credit score is 720 to 740 will be the 14 divided by the sum of this. Okay, so it will be 14 divided by 7 plus 14 plus 25 plus 16 plus 8. So this will be 30, mean yeah, 30, 30, 55 plus 15, 70. So it will be 20% or 0.2. 0.2%, 0.2 possibility, so 20% of chance. 20% of probability that when we select a homeowner, their credit score is between 720 to 740. Okay. And then second question, let me see if it shows. Maybe I should change the color because maybe on the videos you won't be able to see. So second question, the probability of randomly selecting a spade from the 20 card deck. So a spade is just one pattern, right? So how many spades are there? How many cards? 13, right? So it's just 13 divided by 52. So that's 25%. Yeah, 1/4. 25%. How about the probability to get to roll 2 dice and then the sum will be equal to 8? So basically, when we roll the dice, it could be 1, 1, 1, 2, 1, 3, 1, 4, 5, 1, 6, and then 2, 1, 2, 2, 2, 3, right? So with the possibility that the dice will be equal to the 2 dice equal to 8 will be 2, 6. That's one possibility. 3, 5, right? 4, 4, and then 5, 3, and then 6, 2, right? So it will be 5/36 because we have, 2 dice, 6 times 6, so it'll be 36. So 5/36, which is 0.139. Okay, so let's question 3. Let me delete all this. So question 4. So we conducted a survey with 1,025 adults and asked how much they need to give. So these are the results. So 133 people out of 1,025, they don't have any opinion. 41, they will spend less than 100. 164 spend between 100 to almost 245, so almost 250. And then 144 spend 250 to 499, and then 146 spend 500 to 999, and then 296 spend 1,000 or more. So what's the probability if we randomly select someone that will spend 250 to 499? There will be so 250 to 499 will be here, 144, right? So A will be 144 divided by the total. 0.14, 14%. The possibility that someone we select randomly spend 250 or more. So it will be anywhere here, this 3. Okay? So it'll be 144 plus 246 plus 296 divided by 1025 equal 687 divided by 67% of chance people spend more than 250 for Christmas gifts. And then the last one is, to see what kind of probability. We talk about classical, empirical, and subjective. The classical is basically something we can know, like if it's a fair thing, then we know. Just like throwing dice, we know each number will be 1/6. Okay, so the first one, the possibility that baseball player hit a home run during his next at bat. So it will be what? So when you watch ESPN or when you go to ESPN website, you go to the player, the roster, you will see they have all the statistics. So this will be based on empirical because he has all the data. Okay. And then how about this? Possibility draw a jack from a deck of cards.
Possible.
Yes, that will be classical. Like throw dice, like the card or flip the coins. Okay, so those are the classical. How about the possibility I will shoot lower than 90 during my next round of golf?
Subjective.
It could be subjective, and if you keep track of how you golf, then it could be empirical. So it could be both empirical or subjective. Okay, very good. How about the possibility that winning the state lottery? We have certain number we pick.
Possible.
Yes, so it's classical because there are fixed amount of ball we can pick and a fixed amount of number we are going to, how many balls we're going to pick. The possibility that price of gas would exceed $4 per gallon next summer. Yeah, it's subjective. But if you ask, even if you ask Fed, what's the next month inflation rate? They might not know, so it could be subjective. Or some people will say, based on the past data, it could be this. but it's more subjective. Okay, so this is more subjective. How about F? Really, I will finish writing my next book before my deadline.
Subjective.
Yeah, that's very subjective, okay? So this is chapter 4. Any questions?
Do you have another pencil?
Oh, I have a lot of pencil here.
Thank you.
No problem. And then do they have sharpener? Usually they have sharpener in the classroom. Maybe not this one. Yeah, usually they have sharpeners on the wall. Yeah, okay, so we don't have it. Okay, no questions? Okay. So now let me open the next quiz, quiz 5. Great far. So this is the statistics where when he wins a game, how many intersections he has, okay, he draw, or when he loses the game, how many intersections, or you can say the other way around, like when he have, 0 intersection out of, if we look at this way, out of 103 0 intersections, he has better chance, more chance to win. Or, but we see this as the other way. In a game he won, okay, there are different numbers of intersections he caused. Okay, so with this, we will develop a discrete probability distribution. Oh, so what we can do is we can draw something like this. Let me draw a straight line first. So if we are going to draw this, the numbers of the intersection 0, let's say 0 is here, 0, and then 1, 2, 3, 4, 4. There's a like the, how do you call this? Like it's not thing. So number 0, then we have 91 wins. 91 can win, and then we have 12 lose. Okay, and then when we have 1 intersection, then we have 59 can win, and then 37. Okay, I'm not good at drawing, but when we have 2 intersections,
So for A, you have to draw a chart.
you can draw it together, or you can, I'm just being lazy. Like I draw win on the left side and I draw lose on the right side. But you can draw 2 different charts. Okay? Yeah. And then 3, 9, and then 21. So as you can see, when you have more intersections, the gains that he lost is higher than the game he won. But when then he has fewer intersections, the game he won is higher than this. Okay, so in the 4, this is 4, and then 5, 0 versus 1. Yeah, so it just shows, there's a small slight difference, but in some case big. So like if he had 0 intersection, He only lost 12 games, but he won 91 games. Okay,
So you have to draw the graph.
so this is for this one,
Okay.
yeah. So it should be, we should draw two. I just put them together. So you should draw one with the winning game. And you should draw another one with the losing game. But you can also draw like me, like I put it together. Okay, next to each other. So. Okay, so the average B, the average number of intersections drawn by far per game, that was 1. So we are going to calculate the expected return. Okay, so how we do that is we add up all the total, which is 182 in this case, and then for the game loss, it's 105. So you just add it up, and then for each intersection was 91 times out of 182, he had 0 intersection in the game that he won. So this is 50%, 0.5. And then 59 divided 182 is 0.324. And then 23 divided by 182. 0.126. 9 divided by 182, 0.049. And the rest of this is 0. So for the expected return for the winning game, the average number intersection for the game that he won will be this 1.5 times 0, many intersection, plus 0.324 times here 1, and plus 0.126 times 2, plus 0.049 times 3. So when you add it up, equal to 0 plus 0.324 plus 252. Four. 1, 2, 3. That means in his winning game, this is the average interception he would throw. Because he threw a lot of 0 interception. For C, so for C, again, we have to calculate this, so 12 divided by 105. Okay, here, the percentage or the decimal point. The relative distribution. And here is 3, 5, 2, 2, 7, 6. 4, 8. And so this similar to what we did here. So 0.114 times 0 plus 0.352 times 1 plus 276 times 2.2 times 3. me erase this, okay? What I can. It's the erase. Oh, it's not touch screen. Let me erase the previous one, okay? Because I need to write here. Okay, 0.2 times 3 plus 0.048 times 4 plus 0.01 times 5. So that would be it would be so for the gain he lost in average, he threw about 1.746 intersection.
I got 1.76. Would I be wrong if I factor that or?
I think it's just the rounding.
Okay.
Yeah, I think it's just rounding. Okay. And then the variance and the standard deviation would be just the variance would be just seven, 4, 6. But I did. 1.225. Oh my goodness. So we have to calculate everything. So for the variance, it should be so the new for the winning one is 0.723, right? And then for this one is 0.5. And then 4, 0.6, 0.046. So I'm going to just do the winning one, okay? So this one is 0.723. So 0 minus this will be negative 0.723. And we have to do the square of this later on. And then 1 minus this will be this first. Write it a little bit front. So it'll be 0 minus the mu will be negative. But we're going to take square of this. And then the next one is 1 minus this. So it will be 177, or 277. Negative, I mean positive 0.277. And 2 be 1.27. 2.27. And then here we don't need to do anything because it's zero. Okay. So we square this. Okay. 0.23733. 0.723 times 0.723. 0.5227. So when we square this, then when we square this into 77. Did I calculate this wrong? Let me try again. 0.2723. 0.5227. And then this one. 1.277. 1.63. It's 518. So when we add it up, it will be what? Oh, no, we have to use this. We have to use this times 0.5. So it'll be 0.5227 times 0.5. Seven times 5 times 0.5227. So that would be these times this would be 131. Okay. And then 0.076 times 0.324. I rounded. And then 1.63 times 0.126 would be 0. And last one, 5.18 times 0.049. So this will be 0.28. If we add it up, is so when we add up everything, there will be the sigma square. So that will be 0.746, around 0.746, or 0.745 something, okay? And then you square root that. 746. That's the winning one.
Can you explain how you got the 0.5227 and the 0.076?
Where is it? Where?
It's underneath a number of interceptions.
How do I get this? Or this?
It's on the table.
So this one or this one?
That, yeah.
This one?
Yes.
Squared of this. 0.723 squared. Okay. Yeah, because remember we need to square it, and then after we squared it, we need to times the probability. Okay, yeah, and then after that, this is, and then we add it up. We add it up with this 0.746. That's the variance. So this is the variance, which is B. This is the variance for winning game. Okay, and standard deviation is the square root of variance, the sigma. So it should be sigma equal to this. What is this? This is the standard deviation. This is for winning game. For loss game, we have to do this again. For loss game, what's the average? 1.746. So the average is 1.746. So we have to use 1.746 minus, 0 minus 1.746, 1 minus 1.746, so on and so forth.
We still want C.
We are doing D. We're doing D, first part of D. But we didn't do loss yet. Yeah, so because I said two-fold distribution, we only do this one. This one will be, like I mentioned, this is the average. So we use 0 minus 1.746, which is negative 1.746. And then 1 minus that be negative, be negative 0.76. And then 2 minus this be positive 254. And then this would be 1.254. Right? Oh, we need to do the fifth one. So the fifth one will be, wait. 1, 2, 3, 4. Oh, we need to do 2. 2.254 and then 3.25. So we have to do all this. Because they have, we didn't do this because there's nothing happened, so it's 0. So I didn't do it. But for this one, we have some numbers here, so we have to do it. And then we have to, remember I calculate the total and then use each number divided by the total, the probability. So I have to calculate, I have to write it down again. That's 0.114, 0.35, 0.276, 0.2, 0.48, 0.01. So this number, we have to square it. Okay, I'm not going to do it again. I can use Excel, it's easier. Let me use Excel. Oh my goodness. Yeah, I use Excel. Oh, lazy. Oh yeah, the number is still here. So I can just copy. Yeah, I just copy this number because this is the X bar, I minus X bar, okay? The average. So this will be negative 1.746. Negative 0.746. 2.254, 2.254, 3.254. And I'm going to do square root of this to the power of 2. When you scroll down, you just copy the whole thing down. And I usually double click on whether or not it's correct. So it's still this one to the power of 2, okay? And then we use this times the probability here, here, this one. So it's 0.114, 0.352, 0.276, 2, 0.048, 0.01. And then here will be this, the square, times the probability. And then we'll just add, like scroll it down. Usually I double click. It's the right place. And let me, sorry, I'm going to clean all this. And this will be the sum of this. That will be when we add it up, that will be the variance. Okay, the sigma square. So the sigma will be this one square root to the power of 0.5. That's the square root. So 1.107. Okay. So do you know how to do to the power of what in Excel? Use this. You saw that, right? So use this book. Use this symbol, this symbol, which is the key for 6, shift 6, above 6. You see that? Let me show you one more time. It's to the power of 2. Okay. And the square root is just to the power of 1/2. So this is the square root, the power of 1/2. And then the cubic, what do you call the cubic root? The cubic root is 1/3. So it's to a power of 0.33. Okay. Let me double check. Let me see if I can do it. 27 equal 27 to the power of 0.33. And let's do that. Oh, I can do this. Power of 3. Yeah, then yeah. I have to do this. Okay. Any questions? Okay. So that's the number 1. Okay. So what conclusion can you draw from the intersection? From the statistic we just calculated. So in theory, from the statistic we saw, the average, the expected, the average number for intersection for the game he won is 0.723. For the game he lose is 1.746, higher. And then the standard deviation is also higher when he lost the game. Okay, so so maybe when his condition is not stable, when it has more intersection, the team tend to lose the game. Okay. Okay. So second question, your best friend proposed a bet on a basketball court, and you get to attempt 1 free throw. So if you make the 3 throw, the friend will pay you $20. If you miss, you pay your friend $25. So based on your previous, experience, you tend to get in about 65% of chance you will you will make the 3 throw. Do you want to bet or not? So this is also to calculate the expected value. Okay, so if you decided to bet, you have 65% chance of winning, right? When you win, how much do you get? Yes. So when you win, you only get $20. When you lose, how much you lose? Oh, it should be times. So 0.65 times 20, and then there are 35% of chance you're going to lose $25. Will be times negative 25. Okay, so it will be 13 plus 13 plus 25 times 25 times. Is it point? Yeah, 8.75. So it'll be negative 8.75. So 13 minus 8.75 is 4.25. Right? So it means A, you have you have very good chance because this is positive number. It means if you draw, you might, if you constantly draw 100 times, maybe you make $4.25. But you have better chance to win, so you might win $20. So do you want to do it? Yeah, because we have positive expected number. Okay. Okay, so now. It's not really difficult, but we need to think. So, the campaign Napoli, they found out 84% of their customers satisfied with their recent meal. So what's the possibility that the next 5 customers, out of the next 5 customers, exactly 4, they will be satisfied. So there will be binomial distribution. So it will be, we want the P to be 4 when what is this? So we have like 5 customers, okay, to think about. So it's 5 in factor divided by 1, 4 in factor times 1 in factor, okay, times binomial 0.84 to the power of 4. 4 exactly 4 will be positive, and then 1 will be negative, right? So 0.16 of 1. So it should be 6, 8, 39%, 39.83% of chance. Exactly 4 out of 5 will be satisfied. About less than 4 will be satisfied. Then we will do, that means 0, 1, 2, 3 will be satisfied, or we could do 1 minus 4 P4 minus P5. Okay, since we already calculated this, let's just do 1 minus P5, 5 out of 5. 5 out of 5 will be relatively easy. So it'll be 5 in factor divided by 5. So this is 1 here, and this will be 0.85 to the power of 5, and 0.6 to the power of 0. That's 1. So it's actually 0.84 to the power of 5. That's the possibility for 5 out of 5. Exactly 5 out of 5 we satisfied. Okay, so we can use 1 minus Z point minus this one, 4 out of 5, 3, 9, 8, 3, and then 5 out of 5 will be 0.4182. So the answer will be 0.183. Or you can, like we always use, we can use the Excel.
How would you do that on Excel?
Okay,
This was part B.
this is part B, yes. Oh, no, it's already, yeah, part B, less than 4. Less than 4 will be satisfied. So it's 0, 1, 2, 3 satisfied. Okay. This is binomial, right? Yes or no, right? So let me add. So just use binomial. No. Oh, 5, no. scare myself. So this is, so so for this one, it's cumulative or not, right? So we want less than 4, less than 4, so it's 0, 1, 2, 3. So what we can do is we can just do 3 out of 5, and then 0.84, and then cumulative. I don't remember should be this one. At the most. Yeah, so 3, right? 3 is the most. Yeah, so this will be that. When we use Excel, it's much easier, right? Okay? Yeah,
Thank
so
you.
that's Excel. And then the mean of the distribution, mu is equal n times p. So n is 5, p is 0.84. So there'll be 5 times 0.84. Let me write it down.
This still B, right?
This is the C. B is here. This is B. Yeah, this is B. Then C will be mu more and is 5 times 0.84. And then sigma is equal to n, oops, it's P and Q and NDQ. So it's 5 times 0.84 times 0.16. B should understand. Will be. This is B. This. Any questions? Okay. So for this, the next one, we can also use the binomial. Number 4 is binomial distribution. So I'm not going to delete this one. I'm going to put it here. Okay. So what we here we said it says to use binomial table, but we could just use Excel. So we can do binomial distribution, and then the S here is exactly 3, okay, out of 7, and possibility is 0.4, and is it cumulative or not? So in this case, it's not cumulative because we want exact 3, so it's false. Okay, so the answer is 0.290304. Okay, and then B will be at this 5, at this 5. So 5 and this 5 means 5, 6, 7, right? So we should do 4 or lower, cumulative 4. 1 minus cumulative 4. Okay, so let me put 1 here. Yeah, let me put 1 here, and then cumulative 4. Binomial 4 out of 7, and then 0.4, and then yes, true. So it's cumulative So it's 43210 here, or we calculate. And then the answer will be this one minus this. 0.09626. You can just do the decimal after decimal point, then 4 decimal point. Any questions? So using Excel is much easier. Don't have to do so many power. Okay, so quiz 6 is also chapter 5. We open quiz 6. So first one, the cell phone retailer offer insurance plan. And Sarah is a sales representative. Historically, she was able to sell 53% of customer the insurance. So that means 53% will say yes. Okay, so so Sarah has sold. Oops! Oh, what did I do? Share screen. Oh yeah, I canceled. Sorry. It's not shares. I try to enable it. All phones to 16 customers so far this week. Oh, it should be cell phone. Oh. Cell phone to 16 customers so far. So what's the possibility that exactly 10 customer purchase the insurance plan? Okay, so the S will be 10. We move it here. So this is question 1 for quiz 6. So also binomial, because we want to decide yes or no, the customer will buy insurance. So it's how many? She's 10 customers out of 16, and then possibility is 53%, 0.53, and then it says exactly, right? Exactly 10. So it will be not cumulative. So first answer is 0.150963, or you can say 0.1510. Okay, round it up. And then B will be possibility fewer than 10. So it's fewer than 10. So we cannot use, let's see if I can erase. So I'm copying the same thing, but change this to 9. Okay, because it's fewer than 10, so it's 9. And then we want it to be cumulative. So it should be true here. Okay? So that's the second answer. 0.6932. The possibility more than 5. So more than 5 is 543210, not 54310. It's 6, 7, 8, 9, 10. Till 16. Okay. So we use 1 minus lower than 5. Oh, I forgot the equal 1 minus binomial. No, now this time I put a 1 inside. Okay, 1 minus 5 out of 16, and it's by 3, and then it's cumulative because we want more than 5. So this is the second half is equal or less than 5. So the possibility is 0.932. So actually, very likely she would sell a lot of insurance, right? So we can construct a histogram. I'm not going to. We can do a histogram based on the binomial distribution.
So which one is the answer to B?
B is this one. You should try to, did you copy the formula? The formula is more important because it will help you with your test. Okay. No more questions? So second question. So the average number of complaints received by Christina Hospital from patient is 7.4 every 4 weeks. So assuming the number of complaints per month follow the Poisson distribution. So every 4 weeks, we will assume that's also, you know, similar to the month, okay? So exactly 3 complaints during the next 4 weeks. So lambda is 7.4, and then x is equal to 3, okay? So exactly 3 complaints. You want me to show you the formula, or let's just do Excel? Let's just do Excel, okay? So this is follow the Poisson distribution. So we can do Poisson and these two. Yes. So x is equal to 3, and then the mean lambda is 7.4. Is it cumulative or not? The A. Yes. Good. So it's false. So the answer is 0.0413. So the next one. The next one is 3 or fewer. So I don't have to change it. Okay, so it includes 3. So I can say true, it's cumulative, right? Copy the whole thing. So that's 0.0631 or 6315, 632. Okay. Five or more, including 5. So we need to do 1 minus 4 cumulative. Okay? So equal 1 minus this 3. So we do this. So this is 3. I just change this to 4, right? We want 4 over lower, 4, 3, 2, 1, 0. So change this to 4, and then just use 1 minus this. So that's the answer, 0.8605.
This is C or this is for?
This is C, yes. C.
Can you explain again, why do you do the 1 minus?
Because it says 5 or more. So that means this is, the cumulative is 4 or less, right? 4 and less, 4 and fewer. So that's why I do, we do all this like 4 and fewer here. Here, right? This is 4 and then true. Yeah, so that's why we do that. The next one is a little bit tricky. So next one,
That is, I can't see the question.
huh?
Are we on,
Oh, you want to see the quiz here?
this will be on the,
Yes. If you go to D2L, the quiz is there. Yeah, you can download it from, or you can look at it from your computer. So this is D, now we are in D. So you see D, the difference is instead of during the next 4 weeks, now we have to change it to next 2 weeks. Okay, so what is the lambda now? Instead of 7.4, it will be what?
divided by 2.
Yeah, divided by 2. So here, we have to do, what is this? This. So the x is exactly what? Exactly 3, right? And then lambda will be 7.4 divided by 2. 3.7, right? Is it cumulative or not? Yes, it's exactly 3. So that's it. 0.2087. Number 3, also Poisson distribution. We can put it here. So what should we do? So they use the thin film to protect different surface. Average number of defects per square is 0.05. So the Poisson distribution, the number exactly 1 defect in the square. Okay, so the unit is the same, 1 square, and the defect is 0.05. So exactly 1 will be Poisson. This is 1, and then the average is 0.5. Exactly 1, right?
Yeah.
So it's false. Be 0.476. 456. Yeah.
And on the test, we can't use Excel, we actually have to. So,
You can you
Oh.
can use Excel,
okay,
but the danger of using Excel is if you put in something wrong,
right, you can't,
if your answer is very off, I mean, if it's rounding, that's okay, but it's very off, then you don't get partial credit.
okay.
So if you use Excel, make sure you need to go back and check, make sure there's no, mistake. So for, what is the B? What is the B? Should we do? So what's the possibility there is some kind of defect? So basically,
Would be just using 0.05 as your X value. And then,
so we need to use 1 minus 0. 0, okay, 0 chance. So Poisson 0. This 0.05. And then should it be cumulative? I think it should be cumulative. Should it be one? There is a effect. It should be cumulative. Let's try. So that's that, yeah. So, yeah, so anything less than 0 is there. Okay. So that means it's like 95% of chance it's smaller than 0. Because the defect is so small. Okay, so only 0.0488%. Yeah. Actually it's 4.88% of chance. 0.05, almost 0.05 chance is a defect. Number 4, let me show you this first. Oh wait, we didn't do number 3 yet. So number 3, Taylor, oh no, this is number 3 we just did. Number 4. So the company want to track numbers of recoverable injuries by the occupational safety and health administration. So they also use Poisson distribution, average 1.4 injured per month. Okay. So what's the possibility that exactly 1 injury happened next month? So some distribution. And exactly 1 out of 1.4, right? And it's not cumulative. So that's 0.3452. Second question, probability less than 2. Less than 2. So we should use 1 and then cumulative. Okay, 1 distribution and cumulative. So x equal to 1 and minus 1.4 and it's cumulative. Okay, so that's the possibility 0.5918. That's B. D, the possibility that 4 or more. 4 or more. So we need to do 3, 1 minus 3 cumulative. Okay. 1 minus some D 1.4 true 0.0537. So that's chapter 5. Any questions? So chapter 6 is continuous. Poisson and what is it? Binomial are discrete. So they have like 1, 2, 3, 4, 5. Okay. And chapter 6 is continuous. So we will have the exponential, we'll have normal distribution, and we will have, but here and the uniform. So in our practice, we have, let me see, we have exponential. Now we have exponential and continuous. So let's just use Excel for exponential, okay? I don't want to use the formula. But exponential, the same thing, we deal with lambda. So we will still have to like convert it. So first one, the National Hockey League season, Detroit Red Wings, they led the league in shots on goal, average 33.2 per 60-minute game. So assuming the number of minutes between shots follow the exponential distribution. So it's the minute, how many minutes between shots, okay? So lambda is 32.2, average lambda, they have 32.2 goals per hour, right? 60 minutes again, divided by 60. So that means so that means the lambda is 32.2 divided by 60. So every minute they have about 0.537 goals every minute. And then the so that would be the lambda, okay, per minute. So for exponential distribution, we would do here. So first one, exponential distribution. So X is what? The next shot on the goal will occur during the next minute. So it'll be next minute, within 1 minute, okay? So it'll be 1. And then the lambda is 0.537. Is it cumulative? Yes, okay, within that limit. So it's cumulative, anything less than a minute, okay? So that's that. So 41.55% of chance, 0.4155.
Then we're,
A. So possibility that next shot on goal occur between second and third minute, the 2 and 3 minutes. It will be the possibility of 3 minus 2. And we need to use cumulative, right?
the same thing.
Hmm?
So would it be the same thing? As,
1? No, it would not, because the distribution look like this. And the distribution look like. So the distribution look like this. Okay, so the first minute. So this area is 0.415. And then 2 will be between 2 and 3, it will be second minute, 3 minutes. So it will be here. Something happened here between 2 and 3. So we use 3 minus 2, it will be here. Okay, yeah. Oh, I can undo. Additional lambda. Additional lambda. There's the lambda. So here, the second one will be explanation. Point 537 cumulative minus exponential 2. 0.537 true. So both are cumulative, like the chart I draw. So for that to happen in between first and second minute, it will be 14 point some percent. So it's what? 0.1419 or 0.142. That's 1. Any questions? Second question, the possibility of exponential probability distribution has lambda equal to 18 customers per hour. So every hour they'll have 18 customers coming in. But look at the question we have. We want to calculate within the next 45 seconds, within the next 1 to 3 minutes, 2 to 5 minutes, 4 to 10 minutes. So let's convert the lambda to minutes, okay? So in this case, the lambda should be the lambda, let me write it here. The lambda should be 18 divided by 60 minutes. So it should be 0.3 per minute. Okay, but the first question was within the next 45 seconds. So we can convert the seconds into minutes. 45 seconds is what? So 45 seconds divided by this is 0.75 minutes, right? Okay, so in the Excel, put it into C. Okay, in the Excel, we could do for first one, we want next 45 minutes. So P probability to X less equal to 0.75. Okay, so let's do X, no, this is what? Yeah, exponential. So X should be 0.75. And then the lambda is 0.3, right? Remember, I always put comma in between, just like the block here shows you. So even I put 0.75, but I still put comma, and I put 0.3, comma. Okay, you are not supposed to put space, because then Excel doesn't understand. So it's a cumulative, so put true. Okay, so next 45 seconds, so next 0.75 minutes. That's the possibility, 0.2015. Okay, and then within the next 1 to 3 minutes, the same thing as what we did previously. So P X less equal to 3 minus P X less equal to 1. Okay, so we have to do 2 exponential distribution. So first one is 3, and lambda is 0.3, and then cumulative minus exponential between 3 and 1. Yeah, so X equal to 1, 3.3, and then true. So this is second answer, which is 3342. Yeah. Third one is 5 minus 2. I'm trying to be lazy, so I just copy the whole thing down. Double click. It's what, 5 and 3, right? Is it 5 and 3? Or 5 and 2? So 5 and 2. Change the X to 2. You see that? First one is 5, second one is 2. Okay, it should, because the lambda is still the same, 0.3. Okay, so it's 0.3257. Oh, this is interesting. So the next one, between 4 and 10, again, let me copy the whole. Okay, just change the first one to 10. Oops. 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 What did I do? Shoot. 10 to 0.3. Okay. Second one, change to 4. Was 0.2514. Any questions? No? No questions? Okay. Sorry, I'm falling asleep. Tuesday is my worst day.
Yeah.
Because Monday I have evening class and usually I need to have a coffee to stay up. So I did, but after I had a coffee, I couldn't sleep until 1 or 2 a.m. Yeah, I had coffee at 8 and I couldn't sleep.
Yeah,
Yeah, but tomorrow I don't have class, so I don't want to take coffee today,
right.
you know, because I want to sleep today. Yeah, that's why now I'm like, ooh. So, what, where are we? Oh, 3, right? 3, yes, so. So 3, during the lunch hour. Customer arrived at the fast food drive-through window. On average, every 2.5 minutes. Okay, so that means it's every 2.5 minutes, every customer. So in 1 hour of time, or you know, in every minute, how many customers? So every so mu every customer, like every 2.5, like within between customers, there are 2.5 minutes, right? So for every 1 customer arrive, it would take this long. I mean, between 1 minute, we will have this many customers. So within 1 minute, we have 0.4 customers every minute. Okay, so it's just the opposite of the every 2.5 minutes. Does it make sense? Okay, good. So the lambda is 0.4. Okay, lambda. Oh, this is I wrote it wrong. So it should be lambda. It should be lambda. So lambda is 1/mu, the average. So the lambda is 0.4 in question 3. Okay. So now let's see. So first question, within next 2 minutes. Next 2 minutes, so x less equal than 2. What's the possibility? Okay, again, exponential distribution. X equal to 2, and then lambda is 0.4. Cumulative. So 0.5507%, 55.07% of chance customer will arrive within next 2 minutes. More than 5 minutes, customer will arrive. There will be 1 minus x less equal to 5, right? More than 5 minutes. So it'll be 1 minus, 1 minus exponential 5, 4, and then 2. Will be 0.1352. Then between 1 and 4, we should I copy this now? Okay, let me just do it. Show 4.4, and then 2. Between 1 and 4 minutes, right? Minus 1. And then 4. So that's the possibility customer arrive within between 1 and 4 minutes. It's 0.468. Okay, so that's exponential. So now let's go back to wait, are we in? Eh? This is, oh, I didn't open quiz 7 for you, sorry. So quiz, quiz 7. Well, just. So we were, 1, 2, 3, let's do 4 and 5. So 4 and 5, we can just easily do by, drawing here. So 4, they follow the, uniform ability. So assume minimum flight time between the two cities is 140 minutes to 170 minutes. So that means, oops, that means the possibility is between 140 to 170. So that would only be here. Okay, the flight time. So what's the possibility the next flight takes less than 145 minutes? So the possibility it will take less than 145 minutes will be here. But this one doesn't count, right? Because it will only happen between 140 and 175. So it's actually 145 minus 140 divided by 170 minus 140. So that's the possibility. 5 over 30. That's 6. It's 60.67%. Okay, so 4.167. 60.67%. Any questions?
For A, right?
For A, yes. So for B, it will be between. Little lazy. So between 148 to 165. So 148 is here and then 165. So this area, how big is this area compared to the whole area here? Okay, so again, 165 minus 145 divided by 170 minus 140. 17, yeah, 17 divided by 30. 0.567. Okay, that's or you can say 56 points. That's a possibility. A little bit, just a little bit more difficult one is C. So C says they have a goal, 75% of a chance will require less than 165 minutes to complete. Is it meet the current possibility? So we can check what will be the goal for the current possibility, okay? So we could do so let's say the goal is x2 minus x1. X1 is 140 divided by 30, another 170 minus 140, okay, 0.75. So x2 is 162.5. So if the goal is, if we can have less than 162.5% of chance that the flight take off, less than 165 to finish the trip, I mean 162.5, then we will meet 75% of the flight within this range. So does that mean they reach the goal? Is the goal met or not?
okay, so we say it has to be. A minus.
right? So if we have 165 minus 140, that's 25 divided by 30. What's 25 divided by 30? It's 80 some percent, right? So yes, so it's met. Okay, yeah. The standard deviation, mean and standard deviation is basically, mean is just this plus this divided by 2. Okay, so 140 plus 170 divided by 2 is 155. So it's mean is 3 plus 170 divided by 2. And then standard deviation is the difference, 170 minus 140 divided by kind of messy. So the standard deviation is b minus a divided by square root of 12. So it's 170 minus 140 divided by this. So it will be 30 divided by square root of 12. So it's 8.67. That's the standard deviation. Okay. Raise it. So last question. I'm not going to draw, but so we want, well, I still need to draw. Well, so this one is between 130 and 300. Okay, so the possibility between 180 and 260 is 260 minus 180 divided by 300 minus 130. So that's 80 over 170. 0.471. And B is 200 minus 130 divided by 300 minus 130. That would be 0.12. C, x greater than 150, but it can only reach to 300, right? So it's 300 minus 150 divided by 300 minus 100. The mean, again, is A plus B. Mu is A plus B divided by 2. So it's 130 plus 300, 430 divided by 2. 215. And standard deviation is 300 minus 130 divided by square root of 12. 49.1. That's it.
Why is it the square root of 12?
I'm guessing because it's like a triangle. So there's a special ratio to calculate the standard deviation. Yeah, so that's given. Always 12, square root of 12. Yeah. Okay, I'm going to exit this so I can send you guys.